Look up. At any given moment, there are tens of thousands of metal giants suspended in the vast, empty canvas of the sky. Each one is a marvel of human ingenuity, a testament to a dream as old as our species itself. We, who were born with our feet on the ground, have always yearned for the freedom of the birds, for the silence of the clouds. We saw the eagle soar effortlessly, and in that moment, we understood a profound truth about ourselves, that our destiny was not to be confined, but to defy. But to defy the earth, you must first understand it. You must understand the silent, invisible chains of gravity, the unrelenting pull that holds mountains and men alike. And so, we built these machines, these colossal contraptions of steel and wire, each one heavier than 1,000 elephants. And we asked them to do something that seems, at first glance, like a cosmic joke, to escape the very force that defines our world. So, let us ask the question that has echoed through the ages, the question that lingers in the quiet moments before sleep. How does an airplane, an impossibly heavy object, truly fly in the air? Is it magic? Is it a profound misunderstanding of the universe? Or is it something far more elegant, more beautiful, and more logical than we could ever imagine? The answer, we find, is not one single secret, but a delicate, eternal ballet performed by four invisible dancers. For fundamental forces that are in a constant, silent battle for control. To understand flight, you must first be introduced to this quadrumvirate of power. First, there's weight. Weight is the enemy. It is the unyielding, gravitational pull of the earth, the constant force that pulls the airplane down, wanting to return it to the ground from which it came. It is the collective mass of the fuselage, the fuel, the cargo, and every passenger sitting in their seat. It is the anchor of reality. Second, there is thrust. Thrust is the warrior, the force of rebellion. It is the raw, unbridled power generated by the engines, a violent expulsion of air and energy that propels the airplane forward, cutting through the very air itself. Thrust is the force that fights against the wind and against the inertia of a motionless object. It is the ambition of the machine. Third, there is drag. Drag is the resistance, the relentless friction of the air molecules fighting against the airplane's motion. It is the gentle hand of nature pushing back, reminding the machine that it is a foreign object in the sky. Drag is the tax that the airplane must pay for its speed and its ambition. It is the natural consequence of movement. And finally, there is lift. Lift is the hero, the miracle, the very essence of flight itself. It is the magical, invisible force that rises from below, a gentle but powerful hand that pushes the airplane upwards, directly counteracting the pull of weight. It is the force that allows the impossible to happen. So, the grand secret of flight is not one of these forces alone, but the masterfully coordinated struggle between them. A plane is flying when lift is greater than or equal to weight, and thrust is greater than or equal to drag. It is a state of controlled chaos, of perfect balance. But how, you ask, is this magical force of lift created? How does a wing, a seemingly simple piece of curved metal, summon this power from the very air it travels through? For decades, the simple, elegant answer was attributed to a principle that bears the name of a brilliant mind, Bernoulli's principle. Daniel Bernoulli, a Swiss mathematician and physicist, understood a fundamental truth about fluids, and air, as it turns out, is a fluid. His principle, in its simplest form, states that as the speed of a fluid increases, the pressure within that fluid decreases. Think of a stream of water flowing smoothly. Now, imagine you squeeze the stream into a narrower passage. The water has to move faster to get through, and as it does, the pressure inside that narrow passage drops. Air behaves in exactly the same way. Now, look at the wing of an airplane, a cross-section of what engineers call an airfoil. It is not flat. It is curved on top and relatively flat on the bottom. When the airplane's engines generate thrust, The wing is pushed forward through the air. The air rushing over the top of the curved wing has a longer distance to travel than the air rushing underneath the flat bottom. To ensure that the air particles that split at the front of the wing meet up again at the trailing edge at the same time, the air on top must move faster. And here, the magic happens. Because the air on top of the wing is moving faster, according to Bernoulli's principle, the pressure above the wing drops. Simultaneously, the air moving more slowly underneath the wing maintains a higher pressure. This creates a pressure difference, a vacuum of sorts, that sucks the wing upwards from below. The higher pressure pushing from the bottom and the lower pressure pulling from the top create the invisible, magnificent force we call lift. It is a beautiful and counterintuitive truth. The very thing that holds the plane up is not a great gust of wind from below, but a subtle, elegant pulling from above. But lift alone is not enough. Lift is born from forward motion, and for that, the airplane needs thrust. The jet engines are not simply pushing the plane forward. They are performing a complex, violent dance with the air. Air is sucked into the front of the engine, compressed, mixed with fuel, and ignited. The explosion of gases creates a powerful, high-velocity jet of air that is expelled from the back of the engine. According to Isaac Newton's third law, for every action, there is an equal and opposite reaction. The force of the expelled gases pushes the plane forward. This is thrust. It is the raw, violent energy that allows the subtle, elegant force of lift to come into being. And as the plane is propelled forward by thrust, it must constantly fight against drag. Drag is the resistance of the air. It is the friction caused by the air molecules hitting the airplane's body. To minimize this, airplanes are designed to be as aerodynamic as possible. They are shaped like needles, with smooth, tapered fuselages and thin, sharp wings. The very shape of the plane is a compromise, a careful balance between creating enough lift and minimizing the relentless force of drag. So, the journey to the sky is not a single leap, but a carefully choreographed ritual. It begins with the pilot, a master conductor, throttling the engines. As the thrust increases, the plane accelerates down the runway, building up speed. As the speed grows, the air begins to rush faster and faster over the wings. The pressure difference begins to build. The force of lift, the great hero, grows stronger and stronger. The weight of the plane, the great enemy, begins to feel less and less powerful. And then, at a specific moment, a moment of perfect harmony, lift overcomes weight. With a gentle, almost imperceptible push, the airplane leaves the ground and begins its ascent. The great metal giant has finally found its wings. Once in the air, the pilot's job is a constant, subtle act of adjustment. They are not simply steering the plane, they are managing the forces. They adjust the throttle to maintain the perfect balance between thrust and drag, and they use the control surfaces on the wings, the flaps and the ailerons, to manipulate the shape of the airfoil, thus manipulating the amount of lift. A plane is not an object that is simply flying. It is an object in a perpetual state of controlled falling, perfectly balanced by the forces of its own design. And what about landing? Landing is the reverse of this grand ritual. The pilot must slowly, carefully reduce the forces. They decrease the thrust, allowing drag to slow the plane. They adjust the flaps on the wings to change the shape of the airfoil, creating more drag and less lift, allowing the plane to descend in a controlled glide. The battle is reversed, and the forces of lift and thrust are gently, gracefully, defeated by the forces of weight and drag. The plane returns to the ground, its mission complete. But the story of flight is more than just physics. It is a story of human belief. It is the story of us, a species that refused to accept the limitations placed upon it by the universe. We looked at the sky, and we saw not a barrier, but an invitation. We saw not an impossible void, but a canvas upon which we could paint our dreams. And so, the next time you are sitting on an airplane, and you feel that initial lurch forward, that gentle push of acceleration that sends you hurtling down the runway. Take a moment to reflect. You are not just on a machine. You are in a vessel of human imagination. You are in a machine that is, at its core, a perfect, elegant solution to a profound philosophical question. A machine that, through a delicate and beautiful dance of four invisible forces, answers the question of how to defy the earth. And in that moment, you realize that the magic you saw as a child, when you looked up at the sky and saw the eagle soar, was not magic at all. It was something far more beautiful and far more powerful, the unyielding will of humanity, finally taking flight.